Example number 4, and I thought I did this one already, but we'll do it again. Cosine of x, e to the x, and cosine of x dx. If I let u equal e to the x, then du is equal to e to the x dx. Remember that there's usually a dx on the bottom, and then if I multiply both sides by dx, then I'll get that like that. And then if I let dv equal cosine of x, remember that the derivative of sine of x is cosine of x. So to find the derivative of this, I'm just going to say uv minus the integral of v du. All right, so e to the x times sine of x minus the integral of sine of x, the definite integral, or indefinite integral, du, which is e to the x dx. Now the problem with this is we don't change anything, and now I'm going to integrate by parts again.
Not again.
And then I'm going to integrate by parts again. And then I'm going to integrate by parts again.
Yeah, doing that homework last night was rough.
Yeah,
And again and again and again.
How do you know when it's done?
Again and again
Well,
and again.
so here's the
When
thing.
you can take the derivative
E to the x,
of the integral with that.
yeah, e to the x, the derivative of an antiderivative is always going to be e to the x. So we're always going to have this e to the x thing. Now sine is similar, except we're just going to bounce back and forth between sine and cosine, and then you'll get the negative stuff too. So this one's a tough one because it's an unknown integral. We literally will repeat this pattern over and over and over again. Now we can still have a certain level of precision, right? But I'm never going to have, if you know, like an irrational number, the decimals go on forever, right? But if I have an irrational number, I could approximate by going 2 or 3 steps, or 2 or 3 decimals over. I don't need to know all of the decimals. We can kind of do the same thing with this. We can use this, in other words, if I were to do the integration by parts a second time on this stuff, right? This would be minus, and then here I would choose a new u, so my new u would be e to the x, and it doesn't matter if you flip-flop them around or whatever you do. And then du would be e to the x dx. And then if I said dv was equal to sine of x, well then that means that v would be equal to negative cosine of x. And so if I were to use this integration by parts formula, again I would have e to the x, right, times v, which would be negative cosine of x, minus the integral of negative cosine, so I'm going to put the plus sign there, e to the x dx. All right, and so again, this right here, if the only thing I can try to do is the integration by parts. So we're never gonna. This is an endless loop. It's never going to go away. If we keep on going, and I won't waste a lot of class time doing that, we get to the point where we say e to the x sine of x plus e to the x cosine of x minus the integral of e to the x cosine of x, and we were almost there. Alright? Well, that's exactly where we were. And then if you notice, I've got this e to the x, this right here, which technically is where I started. Minus the negative sign, of course. Does that make sense?
Could you just go back down real quick? Thank you. So basically you get it back to what the original integral was.
So you have this thing. So let me start fresh. So what I say is, let me write it like this so you can see it a little more clearly. E to the x cosine of x dx is actually equal to e to the x sine of x plus e to the x cosine of x minus the integral of e to the x, right, cosine of x.
Okay.
Now I said sometimes in some situations this pattern goes on forever and we'll never be able to figure it out. But what do you notice? Just by the nature of this particular product function or composite function of the product of e to the x and the trigonometric function cosine. What if I added
That's what I was going to say.
e to the x cosine of x dx to both sides of the equation? Because technically this is an equation, right? So then I would get 2 times e to the x, whoops. Is that right?
Mm-hmm.
So then what we could do is if I divide both sides by 2, this 2 goes away, and guess what I've just done?
Whoa. You have your answer.
You have an answer. This is a third way that we could do problem number 3 in your homework.